You know, 4 times 2 gives us 8. 4 is also equal to 2 times 2, which is equal to 2 squared. Okay? Now 2 is equal to 1 times 2. That gives us 2 to the power of 1, or 2 equals 2 to the power of 1. Remember, any number a equals a to the power of 1, or a to the power of 1 equals that same number. Basically what we're saying is taking the number to the power of 1 does not change that number. So now here, if we substitute our values in for 4 and 2, we get 2 squared. We get 2 squared times 2 to the power of 1. Now, if we put it in this form, we're here now, 2 is taking the place of a, and m and n are our exponents. Now we get 2 to the power of 2 plus 1. Which gives you 2 to the power of 3. Now 2 to the power of 3 is 2 times 2 times 2, which gives us 8. Show you example with 9 times 27 equals 243. So 9, you know, that's equal to 3 times 3, or 3 squared. 27 is equal to 3 times 3 times 3. 3 to the power of 3. Okay? So we substitute these values in for 9 and 27. 3 squared and 3 cubed. It's going to give us 3 to the power of 2 plus 3. So that gives us 3 to the power of 5. Okay? And 3 to the power of 5 is equal to 243. What we get if we have a negative exponent. How does this rule apply? Well, here, now, for our form, here 5 takes the place of a, okay? 4 takes the place of m, and then negative 2 takes the place of n. Okay? So we still keep the form. So here, a to the power of m, that's 5 to the power of 4. A to the power of n is 5 to the power of negative 2. So we bring down our form, write our 5 here just like you have a there. And now we're going to put in our m plus n. substitute our value for m, which is 4. Then we substitute our value for n, which is a negative 2. So that becomes 5 to the power of 4 plus a negative 2. Or 5 to the power of 4 minus 2. Gives us 5 squared, or 5 to the power of 2. You know, 5 to the power of 2 equals 25. What if both the exponents are negative? You apply the rule. You still apply the rule. You do the same thing. Here, 6 is A. Negative 8 is M. And negative 3 is N. Okay? So we bring down our form. We write 6 for A. You're going to get M plus N. Now what is M? M is negative 8. And then N is negative 3. So you get 6 to the power of negative 8 plus a negative 3. So you add those two numbers together, that becomes 6 to the power of negative 11. And now 6 to the power of negative 11 is equal to 1 over 6 to the power of 11. We're going to get into that next, how that form is equal. So we have our next rule. I want you to write down. That is, we have an exponent to a negative, exponent to the power of a negative. You have a negative exponent. That becomes 1 over the positive form of that exponent. So a to the power of a negative x is equal to 1 divided by a to the power of x, to the power of a positive x. There's another rule. You need to write this down. I'm going to give you all the rules for exponents. So here are your laws for exponents. Three basic laws. There are a few more laws, but we're not going in. It's really not a video on the exponents. I'm showing you this because I want to show you how to, because powers of 10s are exponents. So you have to know the rules for exponents to work with the powers of 10. So this is your first rule. This is your multiplication law of exponents. Here's your division law for exponents. And here's your power law for exponents. You should write these down. Now here, you see the multiplication law is directly opposite from the division law. Here we multiply, you have a multiplication. Here we have a division. In the multiplication, you added the exponents. In the division law, we subtract the exponent of the divisor, which is a to the power of n. It has to be in that order. You don't subtract You don't say n minus n, because a to the power of m is the dividend, or it would be the numerator for a rational or fractional form. Whereas a to the power of n would be the divisor or the denominator. It is the exponent of the